go here, I want to talk about moving to a more minimal byte scanner. I talked about this a little bit yesterday, and I added some changes to the spec there. Overall, they're pretty minimal. I don't think they're going to affect everything, but they're coming up in terms of like being able to represent the constants in the when I was doing the token constant code generation for Go. I was like, this can't be represented as Unicode. I can't use the quote format for printf, etc., because it's binary data, and yet that binary data could be specified, which is what we wanted. So we need to make that betterer. So, and I assume the stream has started. I still have a little bit of research to do to figure out when my stream actually starts. It turns out it doesn't necessarily start as soon as I start to stream. Sometimes it chops stuff off, but whatever. So I'm just going to go ahead and start now. I've added a couple things, so I wanted to go through and diff this spec really quick just to get a handle on this. First of all, I put a comment in here saying that the PEGN spec assumes at least scanning 1 byte at a time. And the reason for that is because there's no computer that I know of that can scan lower resolution than that, like 4 bits or something. So yeah, we have to scan high cipher. So we have to scan at least 1 byte at a time. And that needs, that's assumed. I guess most people would have thought that, but I just want to make sure it's specified, because up until this change, you could have specified a bit field that had fewer bits in it than a byte, and that leads me to the next few changes. So bin range, I did want to show that you can actually have more than 1 byte represented in a bit field here. This is important. I want to have this because it's really useful for doing things to visualize, when you're using a bit field, when you're and that's it. I want to be able to do that. But in order to do that, we had to do some other changes down below, which I'll show you in a bit. Namely, we imply that the initial zeros that round off to the closest byte, and that's not completely obvious from just looking at the spec. Unicode, I decided to go ahead and put the limitation in, very hard-coded before it was just a comment. You cannot have, it is a syntactical error to have a Unicode character that is greater than 10 FFF, which is an int32 completely filled. And it's a signed int32 that's filled. It leaves off, of course, the bit for signing. So that's like 31 bits. And this guarantees that the Unicode characters will never be ever. They won't even parse if they're more than that. Which is actually slightly better than what Go does. Go actually has a bug. I think you can actually print out a U plus FFF in notation with as many as you want. I demonstrated that the other night. But anyway, but you can't parse it. But you can print it that way, but you can't parse it. So you can print out something that can't be parsed by the same thing that parsed it. And binary. So binary, I changed it from bit digits to binary digits, which are just 0 and 1. Binary is a better reference to the base that's involved. I considered making this base 2, base 16, and whatever, base 8, but left it this way. It does say bin dig plus. Upper hex has been changed to up hex plus because I wanted to be able to put more in a line. That's just a minor change. So yeah, but here's the I did put this note in here so that B1 equals B, and it pads it at least to the closest byte, which is going to be 8 in that case. And that is, that's not an int32 or anything. That's a byte. It's just 8 bits. So it doesn't make any assumptions about what kind of thing is being is being parsed and used there. Of course, I had to change the rest class IDs for these other things. Any is now strictly any actually changed. Any was before, and this is actually really good because this is directly in agreement with the Brian Ford original paper on PEG. He defines exclamation point dot as any digit. And in fact, I'm going to put a note in here because those that know the PEG paper will see this as you know as a thing. How's it going, Marzi? If you two listen to the Raw podcast. So yeah, so this literally means any byte, and that is from the Brian Ford paper. Up till today, this was different. It said that it was any Unicode character, and that would have not been correct. So you can literally put any data you want in there, Unicode or otherwise. It's potentially going to change the comment end line definition, because right now anything after a hashtag in PEGN is ignored, and it just doesn't care, and it's literally any. Well, before it meant that at least it could be Unicode and it could be read. Under this new definition, it means it can literally be any bytes whatsoever, and I don't know how I feel about that. I feel like it should be any Unicode character instead, so I might have to change that. And then, but that's really the major definitions that have changed. Upper hex just had a name change. That's all. And so yeah, not a lot of changes there. But they do help understand that we're dealing with bytes here, and so we're gonna do that. I'm actually thinking about the comment end line things that I just mentioned, and I kind of want to go do that one right now. How's it going, guys? Com end line. So the com end line is right now it's a comment. So a comment can be comment. So right now I'm gonna have to change comments definition. So here we go. We've got we have a comment here that allows any, and right now any is any byte, and that needs to change. That can't be true anymore, because we don't want any byte to be in a PEGN specification comment or otherwise. We want it to be at least a Unicode character. So yeah, so that means that this is going to be Unicode plus. All right, and yeah, and I don't believe Unicode is a significant. It's just, I think it's just a check def. Let me go check. Unicode. Oh, whoops. No, that's not true. That's not what I want. I want. What do we want? I want class. I need a class, but it's not any. The class is going to be. Oh gosh. I think it's going to have to be, well, where's my Unicode one? Oh, we have I'm going to have to do a Unicode range, or I have to say any Unicode. Wait, I know I probably have this somewhere. I just have to find it. It can be any Unicode character, so we need a class. Alphanums, no, any. I'm going to have to add one. Huh. Yeah, I do. Any Unicode. Or I have a lowercase Unicode as well as an uppercase Unicode. Would that be a conflict? No, have that for alpha. So yeah, Unicode is let's do that. So So Unicode, it needs to be a Unicode character. Looks like that's a new addition. So that's literally what I wrote up here, which is defines the range of possible Unicode characters. And I'll put that there. This is going to mess with my gold parser for a while, but so I have a number of things I have to do on this, all of which are somewhat boring, but they're things that I need to have done, and they're going to be better in the long term. And we're talking about making a meta language standard. So this is not the kind of thing to rush. I know that's making some people really triggered, and so far none of them have come out of the woodwork. They're all like fine, but this is something I really want to be solid, and I really want to work well for a long time, and I don't want to ever have to rethink it. So, I think the last time the Unicode or the YAML 1.2 standard was changed was like in 2007. And, it's so solid, it doesn't need to change anymore. And if something is that solid, then you don't need to have version numbers on it, because you just know it's not going to change. So that's going to be very, very hard to do, but we want to definitely do that. All right, so we've added a new class called Unicode, and that means any character in the Unicode code plane of any kind, and that's currently the range, and there's no anticipated change for that. There's like hundreds of thousands of characters that are in the private planes at the end, which will probably never be claimed. It is important to know, though, that this 10.0, this is quite a ways away from a full int32, which in Golang is how a rune is represented. And let's go back over here. So now we have Unicode. So yeah, now instead of yeah, we can go here. How's it going? Yeah. That's kind of funny. No. No, it's not going to be ready. It would be fun, but no. I mean, hopefully somebody will develop a language with it that someday will be useful. I know I will make a language. I'm kind of chomping at the bit to get on to use the thing for other things, So yeah. Anyway, I need to reconsider any place where I have the word any. I also need to add a reserved word for Unicode. So Unicode is now reserved, and yeah, and then this is I mean, this little comment is a reference to that. Why do I have Mission Impossible in my head? It's like the weirdest. I played like a little bit of like Back to Life, Back to Reality, and I got a copyright ding. You guys remember when I did that? I got a copyright ding for that on YouTube. I was like, I played like 60 seconds of the song, and I guess that's too much. Live and learn. Sending objects into deep space or whatever. No idea. I am not coming up for air until some of this stuff is done. Also, I'm moving, so keeps me busy. I actually watched the debate. It's like one of the last things I've done. I have to move. Yeah, I have to move. My landlord is, quote, liquidating our home that we live in. And yeah, my wife and I have been renting for a very long time in different places and stuff, because it's just more portable and we don't know where we're going to land. And yeah, it's a kind of, yeah, I mean, it hasn't been as traumatic as the last time. The last time we only had 60 days to move out. 30 days to move out. So, yeah. Liquid home equals no good. I agree. It's really hard. Yeah, considering she spent, oh, I can't talk about it. She spent so much money on the yard. We bought a new fridge and everything. Now we have 2 fridges and no home. It's like, yeah, we literally have 2 great fridges and no home, because every time. State of Davidson-ish area. Well, I don't know. We're going to find out. Yeah. I'm not going to say anything about where I'm moving. That's just something I'm gonna. For the first time in my life, I'm actually going to be able to. I mean, you'll eventually be able to find out where I am. It's not that hard, but I'm actually going to attempt some level of personal privacy. Sounds crazy from a guy who leaves his mic on and goes downstairs and shouts, like, whatever downstairs really loud, talking to my wife. People are like, hey, we heard everything you said. And I'm like, well, yeah. I've gone from the guy who's like a real privacy advocate who doesn't have a smartphone because he doesn't want to be monitored by, to the guy who streams and says he's not going to get a job for any company that doesn't let him live stream. So it's like, yeah, you could have converted your old van into a Winnebago. Yeah. We wanted to do that. That's why we got it. Yep. That's why we bought that. We were researching conversions and everything. Mm-hmm. I was going to take coding education on the road and go to some of the rural areas that need it most and try to set up shop, and have classes. And no, the best thing to do is to just stream. You can reach the most people. It's been insane. It's been insane how many people have already, written to me, personal email, or dropped me a message in Discord and said, thank you so much, blah, blah, blah. So I'm like, hey, if I'm going to make a difference, I gotta stream. I also have to stream stuff that I need to do, that the world needs. That's not just basic stuff, because I'd like the basic stuff too. But anyway, so yeah, if I sound tired, that's why. I was going through the rat poop in the attic and cleaning it all out yesterday and stuff. It's crazy. I can't wait to have a home again. It's just going to be nice. I had a big old suburban home for I don't know how many years. And then got divorced, got remarried, and haven't had a home since. We've had, home is a weird word, right? All right, break. I need more coffee anyway. You guys got me talking. So I'm not going to tell you where I'm going to move. I'll tell you, it's not far away. That's all I'll say. And eventually, after that, we'll move someplace else. And I'm not going to say where that is either. I'll give you the general area. But the way things are going, the fact that I live stream so much, I'm going to try to maintain some level of not anonymity. That's the wrong word, but you know what I mean. So what's up? I've got the Unicode in there. So anytime we use the word any, I need to reconsider that, which is definitely here. You need to put Unicode there. Yeah. Yeah, it's, it is what it is. It's, we're not happy. I'm 52. I don't feel like packing a whole house again. Plus, because I got all this extra stuff left over from when I had a school, I had a business, and I've got like so many TVs and monitors and computers. Actually, did you guys see the NomSec thing that I posted in the Discord? Yeah. I have raised people needs to become proficient in writing software, at least scripts. Yeah, so this is a big deal, man. So this is funny because when I was thinking about getting into bug bounty in January, I have like, I don't know how many computers here, and I can make an entire, Kubernetes system with the power, with microservices, and then have it do this. So NomSec is a Twitch guy. You can go watch him. He's amazing. This is what he does. He has, spent 7,000 on VPS server. He has 3 VPS servers at home. Subdomains take over. He does all of this attacking through automation and code that he's written himself mostly, that's running at his house. And this is like the top tier bug bounty kind of people. And CTF and that kind of thing. And so SkillSec then, no, SkillSec's still here. What are you talking about? Are you talking about the building? No, the building for SkillStack is gone. It's been gone for a long time, but I still teach. Yeah, it's the best. It's the best. Honestly, I mean, there's been different eras, but SkillStack and we had some new people come on. SkillStack is the best it's ever been. I do it entirely from home. It's one-on-one, so everybody gets really, really highly personalized instruction. It's the same cost that I've been charging all along, so nobody's paying any extra money, and I have my weekends. So and it allows me to stream, and I am going to supplement my income with some kind of full-time education. I mean, full-time job, coding Go or whatever. But the point is that yeah, skill stack is fantastic. I'm not yeah. The only problem is I got all these shirts and stuff, but it's not the same thing. So if you know what skill stack was, if it sounds like you might, yeah. So yeah, back in the day, in skill stack we had a space and we had a classroom and we had lots of people at a time. We had 13 people at a time. I mean, at the highest, I think we had 120, 130 total people, and I had an army of TAs who were helping, and we had hundreds and hundreds of people go through during that time, and I was in the heyday. Oh my God, that was the heyday. We were doing all kinds of fun things. We would have game. I have pictures of all that stuff, so, but yeah, since the move, I've had to get rid of all that and go back to. At first, I was one and three people, and now I'm like one on one, which is really funny because that's exactly how I started. And so I've come full circle back to where I was started. Is kind of like a thing where I add on people. Anyway, that's not anything to do with the byte scanner. So people are bored listening to that. But anyways, this is yeah. So go check this out on the Discord if you're interested into cybersecurity and bug bounty at all. This, if anything, and then Rob Tyson, who teaches at the community college, it confirms this is proof you have to know how to code to do security stuff. You can't just run a bunch of script stuff. If you want to really make it, you have to write tools, and look what he writes his tools in. My favorite languages, my top two languages, Bash and Golang, most of his stuff. And then he writes the rest in Python probably because he has to. VB6 because that's actually, this is interesting because after reading this, I'm actually interested in learning VB6. And PHP because why? Because you're going to own all the 50% of the PHP servers in the world. You have to know it. And VB6, he learned that instead of PowerShell, which I thought was interesting. Because why? Because I want to take over those old, Windows machines that are, I can write VB6 for it, compile the code, and then run that in any Windows box. So yeah, he has subdomains. He has a VPS and Linode for his enumeration. He's got all kinds of fun stuff. He has 1,000 plus programs running that are all targeting different things. And this is really what I've been talking about. This is basically Devsecops is kind of sort of like CI/CD that's on all the time. You just turn it on and it just scans everything constantly looking for errors because you can't do that. It would take you forever to look through all the data. So there's AI. There's a lot of opportunity to write languages and grammars here too, by the way. Because why? Because you want to be able to, tell your system what to do very quickly, potentially even through voice commands, and that is the future. This is some really cool stuff that's coming out of the bug bounty world. I think more and more people are going to do this, and tools are going to emerge that are going to be one-stop shopping or black box kind of operations for Devsecops to monitor all this stuff. I mean, he could easily package all that up and sell that to some big company if they don't already have it. This is the reason I show this again. One of the reasons is because if I actually do, one of the primary places I want to write software is in the security space, because it's just super fun and compelling, and it's sometimes it has automation involved, and this is where we need a lot of software to be written, obviously, and there's a huge open market that's constantly changing for software development in this world. That's just as challenging as writing any kind of CRUD, create, replace, update, delete kind of software for an academic. Yeah, yeah, definitely, he definitely is, and he's fantastic. I really love him. If you want to stay into security, he's the guy to watch. But yeah, so. Yeah, I mean, I love that he doesn't use Burb. He uses Zap, which is also Java. They talk about it kind of is offensive CI/CD. That's what it feels like. I know that those terms are not at all accurate, but Um, it's constantly looking for things to break. Zap, which replaced burp in his tool set, is also Java. And I keep saying the somebody needs to rewrite burp and now Zap as a Go application. I swear that needs to be written, dude. It needs to be written. If you write it, it would be so fast and so profitable. And it's like one of the many things I want to write. But I'm too busy talking and streaming to get anything done. So yeah, have a peek at that. I'm gonna go just so I can oh, this is another thing too. Look at this. I love this. I kind of want to do this. So he put here he worked super hard when he was starting out, 7 days a week. Blah blah blah. Uh, Here, check it. So he locks his computer up after 30 minutes and meditates for 10 before resuming his work. So he works in 30-minute increments, and he probably is really intense when he works. I find that really interesting because, the maximum average attention span is 40 minutes. I learned that while I was doing teaching stuff. And you have to break stuff up to get maximum attention. Otherwise, you'll end up tangenting, and my stream has been perfect evidence to that, right? I'm focused on something for less than 30 minutes, and then, squirrel, and I'm off talking about something else. So, so yeah, he actually takes a break and goes and does something. Now, obviously, I can't make that many streams. I'd have to take a break, uh, but I'm, I like this sort of rotation. I'm going to start to do that a little bit more. It's not always to go get coffee. Sometimes it's just to get up and walk around. So, yeah, I think that'll keep you in your best space. The 40-hour work sucks. Yeah, definitely is. So, speaking of breaks, I'm going to go ahead and take a quick break. We've made a couple changes to the spec here that are going to need to be represented in our first gold parser, which is the one that I use to still like check whether grammars are able to be parsed, and I need to maintain that even if I'm going to completely rewrite the next parser and change the node tree, which is going to be the other thing I'm going to do today. I don't know how much time I'm going to have today. I do have to still pack, but I'm going to keep doing that. So watch the fish. I'll be back in a few minutes. You could probably be more efficient if you work 6 hours a day and take Wednesday. Yeah, well, I do that I actually do that, and I've been so much more productive since I took the weekends off. So not to mention that I had four major breakthroughs on my 3 hour walk the other day. I ran for about I don't know about 40 minutes of it, and then I walked the rest of it, and literally talked to myself. I'm gonna start taking a voice recorder, and I had four major breakthroughs in how to handle the code generation, and this is not uncommon. So some of the greatest thinkers in the world, a lot of them, the Parapoetics, and with Socrates, they all walked. They walked. All right. So nice hook. Oh, you like my fishies? I'll be back. All right. Time to write some code. First bit of code's not going to be very fun to watch, but gotta do it. In fact, before I commit this spec change, I'm actually going to keep this diff live so I can make sure to capture all the changes. And if you've been watching me for any length of time, you know that a lot of the changes I make are to the old one, to the old, what I call first gold. This was the first parser that actually parsed a PEG grammar, and I used it to parse PEG itself and create the AST, which is why I need to maintain it until we have automated code generation working, which is going to still be a while. And I'm okay with that. I am okay with that. All right, so let's do, make sure I don't have any other diffs in here that are setting up to go. Okay. Let's, I gotta just set up to do this testing. I'm using a tool that I wrote to just detect changes to the file system, and pretty basic stuff, just shell scripts, and run the Go test suite rather than something else. So it only runs when it detects a change. All my stuff is in my GitLab, and then in someplace in there. My GitLab's a disastrous mess right now. I need to clean it all up. But I promise I will clean that up eventually. In fact, I've been telling myself that on the weekends I'm going to start doing stuff besides PEGN and consider PEGN stuff kind of like my day job, and then work on some of my other projects that I need to work on. For example, I need to integrate. I need to make a tool to manipulate restream. I need to, the statuses in the chat so everybody can see the chat from YouTube and everything. I need to write a better Git repo interface. And I already started that. It's called Gits. I did that on a stream some time ago, which was fun because that's some good GraphQL practice and everything. And yeah, and I need to potentially fix my Twitch, my Twitch tool, but I actually want to change it, not make it Twitch anymore. I think I'm going to call it Live, and I want to be able to mark stuff such that I can put it in the comments of YouTube, and then have people know they'll be able to click on that and get segments from my live videos, as opposed to fast forwarding through fish and stuff. All right. So right now I'm just going to go ahead and run this. And let's see what we can do. So the first change I need to make is I need to make it so home only reads Unicode. So we're going to be in the AST directory. I forgot I need to test everything. So something about testing with Go. When you do Go test, if you do // it will run all tests in all directories and subdirectories, so that you get everything. If you put tests in different places, if you want to, or if you have sub packages, that's kind of nice. I tend to forget to do that. I should probably hard code it into my tool itself, but I don't, because sometimes I just want to isolate my test to one file or two because I don't want to be inundated with all the test results at the same time. All right, so in this case, I also do something a little bit different. I put all my examples. It's more idiomatic Go to put an underscore test file with every one of your things, but that was kind of getting annoying, so I put them in the examples file. And the first thing I'm going to do is I'm going to write a test case to make this change fail. I mean, this check fail. So that would be a check for home. I actually need to write an is function for any. This is all stuff that's just throwaway. It'll be the code will be eventually the logic of the code will be eventually translated into stuff else. Hi, Greg. And so let's get these done fast. I'm going to try to go through these pretty damn fast. All right, so the first thing I need is to do any. Any needs to change. So any has already changed. Actually, this is not right anymore. This is now, what is it? It's this any byte. So yeah, any is now any byte. So let's put that in there. So we're doing all bytes now. Any byte. Original. All right, so let's copy this any to Unicode. And we're going to, what did I do? I changed it to unicode.com. That's very silly, Rob. Unicode.go. So this is actually accurate now, and any can change to be more permissive. This is literally any byte. So, and this is all reading in int32. I need to help you guys see all the different types, so you can understand the different sizes and basic types of Go. That won't work. I don't think we'll do Go types in Golang. Here we go. Types, constants, etc. I'm trying to get you some just a list of all the types. It's like a tutorial. I don't want that. Let's just go skip that. These are not good. I don't know where I probably should. There we go. So here's all the types. Boolean, you have an int 8. I didn't know we had an int 8. That's cool. I didn't know that. We have an int 16, int 32, 64, blah, blah, blah. Unsigned. So, and then you have these things called runes. The rune keyword is just an alias for an int32. And it's not even a uint32, which I thought was interesting. I don't know why they didn't do that. They could have. They got way more than enough space. Might just be because I think int32 is pretty common all over. Anyway, you got all these other types, complex types even, which is super cool. I would love to use those. I don't do enough scientific computing to do that. But yeah, so our smallest increment is int 8. Int, by the way, will automatically use whatever size is built into your computer by default. So this is very commonly used for most code. It's just easier to remember. You don't have to do this. For floats, however, you do have to specify the size. And why do I care? Well, I'm actually thinking about this because right now, even though I'm not going to change it in this first parser, this rune check is actually, well, first of all, this entire check approach is going to change. And this is something I talked about yesterday a little bit, but we are going to abandon the notion of checking certain things by a rune. We're not going to parse a rune every time, so we have a rune to always check. So a lot of these is functions are going to change and be built in line to everything, because we're going to actually give everything a parser and say, okay, what's next, so that it can look at a byte or 5 bytes if it wants to, and that's coming. So right now, if the rune is literally anything, we just return true, which is kind of stupid, but yeah, unless rune is nil. so we could say if r, and it has to be greater than 0, and that's it. No, it has to be a rune, which means it has to be. No, it has to be any. This is a little bit troubling, because, well, the byte system, the rune system in Go is fantastic until it's not. Sometimes, like, by saying it's a rune, it'll say, I'm sorry, that can't be over 10 FFF. and because it's ahead above the maximum number for a rune, and that can be annoying actually. So I'm just going to put if r is greater than 0, we're done. So I know that's like, kind of bailing, but this is going to get us to work. And yeah, I need to change the other name. Change this to Unicode. Unicode. This is in the is category, so that's going to be fine. All this stuff's going to have to be rethought. For the next parser. But we know what we're doing a little bit better, so this will be fine. And Unicode, any Unicode, right? Any valid Unicode code point. And that means it's including unknown and replace, which was not included before, and that's now allowed. So, yeah. Unicode. All right, so that one's done. Go back to our next one. That does mean our comment has been done. We have to redo home. AST. Let's go change the home example, make it break. Uh-oh, we have an infinite loop going on. What's up with that? That's not good. I have a problem. I must have broke something. What that is. I'm pretty sure I did. Yep, we have an infinite loop. That means that something that's reading, that was reading any, is now broken. So yeah. Original PEGN specification. I mean, it should be any byte, so it should be any. This is kind of just a formality. I really want to get past this thing. Where is this getting called from? Oh God. All right, so AST comment, that needs to change. Well, that's one of the ones that has to change, so let's do that. Let's just test comments for now. Run. No, test to run. What is it called? Let's go into the AST. I mean, this just isolates it. Yep. It's got an infinite loop going on. Well, okay, we'll fix this. Any needs to change. All these comments can go. This is not I don't know. Just no. Turn any Unicode. And so check is Unicode. There. Now it passes. Yeah, here's the problem, is that any kind of needs to go away, because even the final yeah, I mean, the spec's gonna have to change in some case. I'm glad I put Unicode in here, because any is literally any byte, which includes the end of data. So, any is included as a class for people to use, and therefore it's not actually used by the PEGN grammar itself, and that's important to note. So any is meant to show, it's meant to be used as a class, but it's not going to be used by the PEGN's own syntax, because it would gobble up the end of file character. And I don't know if it's a flaw in the parser or what, but the parser right now is always looking at the next thing, and it gobbles up until it gets that thing. And so if you say any, then literally anything will pass. That means end of data will also pass if you're looking at, if you got a parser that's kind of got this idea of whatever the last rune was. That was the last thing that was parsed. And I actually fundamentally want to change how the parser works and have it more in line with more traditional parsers that don't have a scanner built in. In fact, we're going to have to revisit the whole idea of whether we have a scanner at all. A scanner is the thing that just lets you scan the next iterative thing, and then go forward from there. And I actually want to revisit that entire approach and just have a very, very baseline scanner that is not at all, it doesn't have any notion of that. You would literally just set the byte positions on the slice that are looking at the buffered input data. And it'll be faster and it'll be more direct. And I'll explain what I mean later. Anyway, so what else do we have to change? We need to change home and the examples. Examples test. Wait. Oh. What? Where are you coming from? Oh. There it is. The emoji on that should work. And we'll change home. AST home. Is Unicode. And that's, again, I don't care to go beyond this. This is just to keep my gold parser in line and running. Yep. So all our examples are passing right now. And that change is a small enough change that I don't feel compelled to update anything else. We got all that. We have binary range. It was just a comment change, so nothing changed there. Unicode is more precise. This one is really important. I'm going to make sure to add this. No, I'm not. You know why? Because this limitation is never going to get picked up by the current parser. It's never going to exceed this. So this is just a clarification of this. It allows it, makes it so that Unicode can never exceed maximum Unicode size. So that really doesn't need to change the code, this first gold code. And the binary digits, that was just a change in the name. They're now called bin digs instead of, so upper hex, change the up hex. That doesn't need to change the parser. That's not significant enough of a change. We changed the any in the Unicode. We added the Unicode is class. We didn't change that. We don't need to. Upper hex is up hex now. And that's it. That's all there is to it. So yeah, that's great. Okay, so let's just make sure that my tool builds. But I think we're good. What's a minimal byte scanner? It's just a byte scanner. Just yeah. If you want to read about the project, you can go to PEGN.dev. But if you're unfamiliar with compiler and parser theory, you might want to read up on that a little bit first. And so clear. We're going to go ahead and clear this. Yeah, we got the spec in there. Okay, so now what? We need to go rebuild the AST parser that is in the PEGN tool. Go install. Should get this clean compile there. And go back to our spec, and we should just generate a new AST long, which should be the same. And let's do what am I doing? PEGN grammar.PEGN. So all the way down to walrus looks good to me. Just to be sure, though, actually, yeah, let's do this. Let's grammar st long, and then we'll do the AST to the AST, and then we can get diff that. Just want to see all the changes. Okay. Wait, it did not make it a. It did not make it a reserved class ID, which means I missed something. I'm glad I did this test. So, yep, it's not a bad flaw, but yep, upper hex is. Oh, you know what? I changed upper hex to be up hex, so this is good. I caught some errors. Bitdig for bindig, that one needed to change. So yeah, upper hex didn't get it changed. So yeah, I that's super cool. I just like found some problems with my grammar. So up hex, upper hex. I must have an upper hex somewhere. Maybe not. It should have been detected as a reserved word. Oh, that's right. I know what's going on. Okay, so I have not changed the reserved word parser, and that's what's giving us crap. So I need to do that. So let's change the reserved class IDs. We need to add those and change them. So this is actually going to blow up some tests, which is probably a good thing. Up hex is going to change, and we're going to add a Unicode. So down here we can do that. Add comma, Unicode, and change this to up hex. So yeah, that should cover those changes. That should make it a reserved. I doubt that that's not gonna. Oh wow. I guess that's fine. So yeah, I have to rebuild the parser tool, and I have to go back to the spec, and then we're gonna do the same thing we just did. AST, and I should probably do those in one line at some point. Get diff AST long. All right, so that's more like it. Now it says it's a plain class ID, and it says it's a res class ID Unicode. That's what we want. That's fantastic. Okay, we added a comment, so that's now in the AST, or the parse grammar, whatever you want to call it. Not really. I keep calling it AST, and it is, but I've been reading about the difference between parse trees and abstract syntax trees, and the parse trees are the data that has been parsed that you're then comparing against an AST tree, which defines the grammar syntax. And in the case of this PEGN thing that we're doing, the parse tree and the AST are the same thing. So it's confusing because we're literally using the AST to check itself. This is interesting. Okay, res class any. That's still a problem. So yeah, why is that? That should have been a reserved class ID, and it wasn't. In fact, it used Unicode as a check ID. That is a problem. We have to figure that one out. A plain class ID. I don't know that. We can look at that. I think. Let's see. What is that definition? I have to go find that definition. This is a problem right here. We got to figure that one out. The comment is fine. Yeah, there we go. Plain class ID. What's class ID? Upper hex, min max. 4 to 8. Well, that really changed. Yeah, that's a big old expression now. That's good. That's supposed to have changed. This is saying it now wants rest class ID min max 4 to 5 or another sequence with the 10 upper hex. That's fantastic. God bless grammar parsing. That's good. That change is good. Into bit dig, upper hex to up hex, minimal change. We added another sequence on the end of X digits. Now we have Unicode. Yep. And class range, let's see. The binary range is from 0 to that's a change. That's a big change, actually. And then there's our any, which also now has a comment in it. And that's interesting. Okay, so then we have our class ID, res class ID, Unicode. Okay, that's good. That's the one I was afraid of. So that's what it's supposed to be. Class ID, res class ID, bit dig got changed to bin dig, which is fine. Upper got changed, and so I think that's got everything. There's one I want to just be really sure on. Where it said it is a check ID. And that, I don't know about that. That should probably not. I don't know. We'll see. Check ID, check ID, check ID. That one's good. That one's good. That one's good. That one's good-ish. This one's really good. Check ID. Okay, so this is what I'm having trouble with, because this check ID for Unicode might be wrong. This used to be where is this? So I have to go search for that. Check ID Unicode on line 288. All right. ST. So this is a node definition. Enabling check ID, res check ID, end line. Nope, that's not it. Oh, it's down here. Nope, that's not it either. Where are you? I mean, it's probably nothing, but you know, worth looking at. Do 291 maybe. Why is that a plane? Oh, right. But I want to know why. How did that get changed from before? So that's up here. Oh, okay. Yeah, that's okay. I'm all right. I'm okay with this now. So this up until this point was. Actually, that's wrong. Man, I'm glad I checked. That should be the class. That shouldn't be the Unicode character. It's a totally different thing. Yeah, oh my god. That was a bad thing. This would have had them put a whole bunch of Unicode with the U pluses, which is not what I wanted. God damn, I'm glad I looked at that. Yeah. All right. So this here is a comment, but I want any Unicode class character, not a Unicode node. They're different. And I know that's confusing, but that's fine. A node is, is a node, and a class is like one of a set of things. In this case, bytes actually. So byte is the smallest possible thing you can represent. So in this case, a Unicode plus is like, so that was the right answer, which means I got to regenerate. So I don't have to redevelop anything. I just have to. So the AST long needs to be a thing. And the other one needs to be a thing. And I'm 90% sure that that's going to be fine, but whatever. Yep, there we go. Class, what? No, different one. There, that's what I wanted. Res class ID any, res class ID Unicode. So that makes me happy. That's why it triggered my alarm bells. Super glad I checked that. I need to start. I've been using a lot of things I've known about in Git for a long time, but I've been using a lot of things that I have not used in the past as much. So yeah. Yep. That's good stuff. Upper hex, bit digs, bin digits, sequences. That's all good. This is interesting. Actually, that's an error. Once again, god damn. This is not stuff I can write test cases for people. That's the problem. So that's why I have to spend so much time poring over it. It's like writing test cases for a new language that doesn't have. So changes are a big deal. That's why I have to go over them so carefully. I mean, you can write test cases for anything. Technically, I could write a shell script for this or something, but this is a thing. So the problem with this is that we actually have I think we have bitdig somewhere else. I'll bet you anything. No, we don't. And that's not in the reserved class IDs. But it should be. This is one that's been omitted. Hex digit, lower digit. Oh, we have bindig. We have it right there. Well, then what the... please don't tell me there's another bin in here ahead of it. Why is that not a thing then? All right, one more look at this. Let's see. Resi code, bindig comments, fine. This changed from bitdig to bindig, but they're both planes. What I want to know is why they're planes. They should have been reserved class IDs. I have a feeling. 1474. Bindigs. There you go. Oh, I see. Okay. Yeah, this is fine. This is just a listing of all the res class IDs. So these are just words in this particular case. So yeah, that's what's going on. These are just words. So they're fine to be planes. Yeah. Okay. I just love it. I'm just taking a moment to like be happy that I can actually look through all this stuff, and then it's all getting generated without much problem. It's like when you write a lot of code, you start to get on yourself for the stuff that you haven't finished. I'm constantly thinking about that. But it's sort of fun to look back and think about the thing you did create up to that point, and go, this is a a pretty big effort here. It's easy as a developer to be unsatisfied with what you have because you're always thinking about the next thing you're going to make or how much it could be better. And we talked about pulling a Babbage, and that's what I mean by that. I don't want to pull a Babbage. A Babbage is not finishing anything because you're always seeing the new way to do the thing. And so once again, the work I've talked about this a lot, but the work I'm doing right now is, in Babbage's terms, I'm finishing the difference engine so that I can work on the analytical engine, which neither of which he did. Didn't finish either of them. And to his credit, he had to revolutionize the machining industry in England in order to even make the things. But so yeah, I'm just taking stock of this thing that works, that I have, that is wonderful, that has lots of. It's like old to me when I look at it. I was like, oh my god, that was so stupid. Why did I do that? That was old. I can do that better this way. But it still works, and I'm going to maintain it until I have an absolute replacement for it. And that is my commitment to not pulling a Babbage. So yeah, I think we can actually redo this, the good code, because it turns out it's unnecessary. Always breaks my heart. Me too. Oh God, the hardest part for me on this whole project to throw out, just I'll confess, is what I thought was this clever pseudo syntax in my expect thing. I actually wrote a huge document about it. Another thing, don't prematurely document shit. Wait until the thing is done and then document what's left, and only write minimal documentation to keep yourself on track. Because if you try to write all the docs, you're going to chuck some of your best stuff. Yeah, it is. Prose. Oh yeah, prose is the same way. Yep, completely agree. So, but this like really beautiful little type switching beauty is 100% unnecessary if you walk the tree properly. If you actually use the parse tree that you created in your abstract syntax tree, this is completely not required, because you can apply an unlimited amount of logic in a case statement that is in a callback, a function that walks your entire tree and makes and has code in it that's specific to your AST. So, and not only that, but then you can associate these little sub things with a table of first class functions that can then be run. And I'm about to do all of that. That's what's going in the new parser. So this entire thing is just garbage. Totally garbage. And it really, you know what though? This was able to help me get my head around what it took to write all of these parsers in the first place by hand. Oh yeah. First class functions are, of course, yeah. There's not many modern languages do not have first class functions these days. So, but yeah, and I make extensive use of it actually. That's what this is, right? So it's type switching right here on type. This is a struct. This is a struct. This is a struct. And over here, this here, whoops, where is it? One of sequence. Those are all structs. So I'm type switching based on what type of thing it is. The reason I'm showing is, so check here. So check used to be a first class function. Class used to be a first class function. That's now a struct, so I can put more error messages in it. That was the last thing I did on the old parser before I moved it over. Because I was starting to do error messages because the thing is finished, right? And then I started to do error messages. I was like, man, I need more data about what this thing is. And so I had, instead of just passing a single first class function, I had to encapsulate it inside of a struct and then pass that. And then and then I can pull down the error messages that are stored with it. And that's what you see in this whole is stuff. That's what this is all about. So like if I have a word, this is, I have to have kind of a singleton of it because it's got to be a struct. It doesn't actually need a receiver. So this is just a way to group everything together, which I've I throw this whole thing out too in the new one and just made an actual struct instead of a struct that implements the interface for this. I've gotten rid of interfaces in general in the new parser, and I just don't think this is the place to use interfaces. Interfaces are to allow other code to work in its place and to be able to swap stuff out. It has very specific usage, but the level of indirection necessary to implement a function for each one of your, otherwise like struct identifier accesses is just unnecessary and wasteful, actually. So I got really crazy into interfaces. I do that. I get like really obsessed with something because it worked out in one area, and then I'll try to put it in everything. You guys ever do this? Yeah, I'm really open with my failures on this stream so that you guys cannot get stuck in my mental traps. And one of those traps is that I get into a particular way of doing something, and then I end up shoehorning that way into what I do for everything, and find out now a struct would have been totally fine here. And over here, oh my God, why did you use a struct? You should have used an interface there. Best tool for the job, best approach for the job. And that's the craft of software development, is knowing how to design it, how to anticipate the needs without overly freaking out and creating some terrible abstraction fly script, like what Brian Cantrell calls it. Because you've got so much, well, what if in your design that it ends up being completely unsustainable? So it's a balance, it's a craft. And it's not anything they're going to teach you. It's something you've got to just practice. And so yeah, get back to what I was doing. I think the reason I'm pausing here is because I'm actually at a stopping point. Again, I'm going to take another break. I'm going to try to stick with my 5 to 10 minute breaks, and I'll keep streaming. I may turn my sound off though, so you don't hear me talking to my wife. But so yeah, but we're ready. We've got the spec has been revised. I have these new changes, and now I'm ready to go forward with the next changes. And the next changes are going to be basically writing a parser that, I don't even want to call it a parser at this point. I want to call it a scanner, if that, and because the parse functions are the actually things that are doing the parsing. To call it a parser is a little bit of a misnomer, because the parse functions are the things doing the parsing, and they're pulling those things out. But I guess you could call it the parser because it is encapsulating that whole thing. But and then a parser / scanner. So that's going to be the next thing. It'll be based on bytes and not Unicode runes. So I'm pretty good. How's it going, Bluetooth? So let's go ahead and look here. So I'm just going to do a git add, git commit, and we'll say, let's see, changes for byte centric parsing. Yeah, I'm gonna go ahead and skip push that. And then I need to I guess bag and tag this. So yeah, let's go ahead and get rid of that. Just one last test to make sure I got everything. Yep. All right. Git add -a dot. And you should do that. Pray. Oh yeah. You don't want me praying for you. God doesn't want to listen to anything I have to say. Well, the God that I used to believe in anyway. The angry white guy in the sky. Yeah, don't believe in that so much anymore. All right, so you finally installed Alacrity as soon as I got rid of it. Did you see how I got rid of it? I dropped it. I snuck it out. I was like, I don't need this. It's too buggy. Yeah. It's fun. It's good, huh? It's good. It's nice to be able to have that YAML stuff. Yeah, I got rid of it. I was like, I don't need this. It's not that much better than. I mean, it's great. The YAML is the reason. To me, the YAML is the kicker, because you can adjust anything at any time, you know. Also, I want to be able to make a better group box theme that's more better. My the one that I have now is a GNOME terminal that I just kind of tweak the colors, and I was like, no, you don't have any kind of control over your colors with GNOME terminal. Anal retentive like me. Post git commit. What are you talking about? I don't even know what that means. I do. Oh, right. Have more code. Ha ha ha. Yeah, this is me. This is me. Oh my god. I gotta read this. This looks really fun. Yeah, this is me, dude. That's I've committed to permanently never doing that. Not even on my own projects. Yeah. So, yeah. Here's the problem. I've talked about this before. I'm largely involved with writing, lots and lots of writing, and the amount of git commits I have to do to make typos and spelling corrections and everything like that is like overwhelming. And a lot of times I want those things to publish immediately. So I've had to really think about how do I apply my Git workflow to writing versus software development. Software development is pretty easy to be more dedicated to doing what I should do, which is this, make and change background color from SysG's bright white hurts mice. I don't even know. Do not know, and that's an unrelated question. I'm sure somebody here could maybe help you with that. So let's do this. Let's say, all right, adapted to spec changes for byte centric parsing. Somebody might know. You might. I wish I don't have a Discord chat for SVG stuff, but oh shit, Git. Another good one. Well, there you go. Yeah, good old bash. Oh shit, Git. I committed and immediately realized I need to make one small change. Hello. The problem is the amends is that if you git push like I do, then git amends do not save you. They don't save you if you've pushed already. Nope. Oh, this is maybe. There you go. This is a really good one. Oh my god, that's going on my top of my list. Gotta go read that one right away. That is awesome. Thank you for that link. We watch fishes. We watch fishies. There you go. Fishes for fun. I'm gonna go have a little. Oh wait, I forgot to tag it. This is annoying. I actually kind of just want to. I don't know what I want to do. I want to change it because I keep having to tag this first gold. I actually think it should be the branch and master should be something else, but this one's the one that works. So it will stay master for now. Master. But it means I have to move the tag every time because I have to keep making sure that it's the last good version. And eventually that will be a branch. And then there's no real good master branch. I still want this stuff on master to be completely and totally usable as is, which it is right now. So yeah, fish. Talk to you soon. back to minimal byte scanning. Yeah, you can go away. You can stay. This can go away. And the spec can stay. I'm going to need that. Testable stuff. This is what I was working on my other parser. So this is going to be... So this is kind of what sent me down this road, is trying to get end of data to represent properly, and I can't render it, I can't generate it as a constant, because, at least as a string constant, which kind of leads into all kinds of problems with the node tree, having values that are strings and stuff, which I talked about in the other video before this one. And yeah, so there's got to be some rethinking here going on. Not a lot, but enough to cause me to rethink the parser itself. And so I'm having a little trouble here getting my head around how to go about this. One of the things that I can continue to do, which is not very testable and sustainable for this first verse. So I kind of have... So I have the master branch, the first goal. They got to maintain that and keep that working, and that's not ever going to change because I need that tool to continue to work. And then I've had this one file parser, which is in PEGN, which has been sort of a model of what will be generated by automatically, and so I'm using this as the basis for any kind of generation. And the active code generation is a lot like compilation, I'm finding so far. You take an AST, you walk through it, you use that AST to take in another parse tree and then to transform it into something else. That's what your interpreter does, or your compiler does. And so the output of that in this case would be a single file that can be embedded in your project and allow you to parse your own grammar. And I've already talked about the different approaches to this. I've written these up in here as well. So there are three distinct cases for this particular package. We want to generate standalone single file parsers for any grammar that don't have any naming collisions, that from the PEGN tool that I have, I can be able to generate and say, hey, what do you want your prefix to be? And then it will create a totally encapsulated private single file that can just be plopped right down into the middle of your project with no problem. And that can actually even be generated over the web or through some sort of command line interface that talks to a remote tool, rather than having to just download the tool or whatever. Whatever, the generator is going to make a single file. And then the other use would be inline peg parsing to replace regular expressions entirely. This is one of the things that I cannot wait to get working. And it's a different use of the entire thing that would walk the abstract syntax tree against the parse tree in real time, and do a check to see if your thing matches, and or give you back a generated AST without having the code for the grammar be pre-generated in any way. So these are both what I've found in my research is these are both two things that are commonly done, all over an interpreter or compiler land. They're out there. They're not new by any means. They're new to me, but it's kind of nice to know that there's people who've been doing this for a while. There's certainly not anybody who's doing this with regard to PEG in this way. All the PEG generators that are out there right now are just to do this first item number one, just to do standalone. This is all Markdown. That's why these are doing this. In Markdown, it's kind of bad form to not use ones, because then you can't reorganize things without renumbering everything. So we have inline peg grammar parsing to replace regex. And then the last is just to evaluate grammars and ASTs and stuff like that in general. And while I found the first goal parser to be a good example of how to do this. In fact, I plan on probably keeping that branch around for that reason only, but I don't want it to get in the way of the final product for the tool. So I don't want to be cutting corners. Like when I very first did this one, I did the node tree and the parser as an implementation of an interface, and I did all these things that are kind of proper way to do code. And one by one, I started like dismissing those things. I'm like, no, this is an internal parser. It needs to be efficient. It doesn't need to give a shit about how it's going to be used. It has to have an interface and everything. But going through the process of writing those interfaces and then implementing them was a very good sort of academic exercise, and I did it sort of because I was testing the water of how I would teach this to someone else, and it worked very effectively. In fact, a couple of the people that I've been working with wrote many of the parser functions, and they were able, I believe, to get their head around what a parser is and how it works a little bit easier because of the way I approached it, and because of, I use public things and separate packages. It just this first gold thing that I've done is not particularly it's not transportable, but it's good for an academic look at how you would make your own parser, and if you wanted to really separate these functions and stuff like that. So imagine that'll still be around. This is not a very primary need. But right now, the number one most important use of this tool that's coming out of this is being able to generate parsers just from a grammar. So if I have a grammar, boom, I run my thing, and in milliseconds, I have code that would have taken me, week or so to write if I had to write it. And I can actually go in and tweak that code for things that cannot be represented in a grammar, such as indentation and things like that. Which are not super important, but you still need them. So that's where I'm at. And now, so what's next? Well, I need to make a decision here because I've been doing this PEGN.PEGN.Go file, and I've been sort of simulating what it would look like in its final version. But the problem with that is it's not very testable. It's not. It's the final version, the one, the one file that gets generated by the tool is it may or may not have its own test cases written up to go with it, but largely it's not going to need that. For the most part, and that's what I have here with PEGN_test. So why am I talking about this? Because this is me coming to the conclusion that I kind of need something fresh that just has the parser code in it, and something fresh that just has the node tree in it, and or both of them, and that is not trying to be a simulated one file, so that I can get to the point where it's testing. And then I'm contemplating creating some sort of generator or make tool that would take this stuff and put it together into a single file that could be that simulates how it would be generated. And I kind of need to go through that process in order to figure out what the code generator is gonna be. So I suspect. I mean, I don't know if that's a new branch or what. I think I'm just gonna. I and then again, it comes down to maintenance, right? So, what ultimately is going to be the package that gets published, right? So, what is PEGN Go going to be? Is it going to be, this one input sort of thing? I'm leaning towards making it so that the PEGN grammar that is actually the final one is nothing but me having run the PEGN tool on the PEGN grammar, and that's it. In fact, it's so streamlined that I've considered even just putting making the spec also an implementation of the grammar because it's of the package, because it's just one file. And this is another rabbit hole that I don't want to think about right now, but later on when we eventually create a registry for all of our, this is a hands-off registry. It's kind of like the Go docs. You just go there and see it. But it's possible that we could actually have, multiple parser implementations in different languages in single files within the spec. And that feels like it's too much putting too much together in one thing. I am kind of trying to figure out, well, what is what is this spec repo going to look like? And because I do really want this idea of being able to have, consistently organized repos of any particular grammar. So, for example, grammar.PEGN would be the standard name, and then you would have, maybe you wouldn't necessarily have to have a manifest. I have a manifest in this file because this is also a knowledge node, and that's actually kind of a convenient thing. Is that the spec is also a knowledge node, so it doubles as a website. So you can go out to, you can go out to PEGN.dev, and this is, it's multi-purpose. It has all the documentation from the README. It doesn't right now, but it can have testable examples that generate into test code. It has, links to the actual grammar. So you can go download the grammar and get it this way. You could even curl the grammar down if you wanted. And, and so it's hard for me to not go one step further and say, okay, now I also want the Golang parser to be here. And I don't feel like it belongs here, even though I kind of want to do that. By the way, this is a submodule. That's why that's listed inside of PEG1 Go. It's not actually there. It's a Git submodule. So this is not really a thing. Anyway, and so I think I just ruled out kind of audibly that I'm not going to put this one file thing into the spec. So what that makes me believe is that there's an intermediate step between my first gold and second gold, or whatever this is, and this is going to be kind of a rethinking of the whole thing. And it's obviously it's going to have to include writing some of those check functions and stuff, but I don't want to write those. I want to generate those. But I definitely need the parser to work, and I need the node tree to work, the new node tree to work, and cannot do that. Well, mostly I just need the parser, and it needs to be built on Byte scanning, and I can probably change the one that's here, but I won't be able to test it very well, so I need to put it in a separate place. And this is kind of a catch-all dirty directory right now, so assuming I have some stuff here, I'm going to go ahead and just make a directory in here and just come back and deal with it later. Again, this is kind of a working directory, so it's going to get lots of changes. This is not master. This is a kind of experimental branch. I can chuck the whole thing if I need, but I can still commit to it for those who want to follow it. So I'm going to make a directory called parser. I don't really want to do that though. What I want is everything to be in it. I mean, you know what? Fuck. Well, I don't have any collision yet. I'm not supposed to swear. Sorry, guys. I'm supposed to not swear. I'm trying to get better at not doing it. What time is it anyway? All right. So I don't think I have a parser defined already. Let me just check. Well, I take that back. We have the JSON parser. And that took me down a rabbit hole too, because we want to be able to generate stuff with the proper prefix, blah, blah, blah. Eventually all that stuff's going to go into a template or some sort of, they're going to go into the generator. Fill the scan for the first rune. Yeah, we have a, yeah, we already have a PEGN parser in here. So yeah. I might just do another branch, but then I have to keep this branch around. I think that I'm going to break this up, and then we'll put it back together later. The real question is whether I should use the same naming conventions I'm anticipating for the whole thing when it gets brought back together. I don't really think I need that. And I considered like, well, how am I going to take this existing code and then not have to maintain two copies, right? The one that gets generated in this one. And there's a number of ways to do that. I think the best route here is going to be to create the final versions, the private final versions of everything, and then move them into a generator tool of some kind or function, and then use that to generate them, and then maintain the stuff in the generated area. And then every time I want to do testing, I'm going to have to regenerate it. But that is so annoying for maintenance that I do not want to do that until we're really ready. Because otherwise I'm going to have to regenerate every time I want to do any testing, like for every change. And that's just super annoying. Another possibility would be to keep all the stuff in its unprefixed form and to create a generator tool that actually uses the Go AST tool and walks the Go language and adds the prefixes automatically while it's generating the code. That's totally doable, but that's a little bit more involved generator. And of course, the final way to do this would be to just do all the names from the beginning, using this, using the assumption that this is going to become a single file and it's never going to be used as a package itself. And that is that's a different sort of thing. I don't particularly like that because it's just ugly. But yeah, all of those are options on the table, and that's why I'm just kind of thinking about this right now. Yeah. So, I really don't want the prefix in the version that I'm working on to get it all working. I want to be able to change all of that. And I mean, that's going to go in the generator at some point. So the question is, how do you get the code that you're using in testing to be put into generator form, so then you can get your one file out of it and have all of it maintainable. And I have a feeling that it means that I'm going to have to generate the code for the library separately. Or that the generator code is going to have to, walk the AST of a thing and use reflection, which I could totally do too. So I don't know. There's just a lot of ways to do this, and that's kind of tripping me up. There's some actually pretty novel approaches to this that are only possible in Go, and that's one of them is the AST. So that would be theoretically. I've never done it, but theoretically I could just write this, and just like as if I were writing it, but with the sense of I want everything in the same namespace. That would be the only requirement. I could just write it all out that way, and then I could deal with that code base and write another bit of code that takes that code and transforms it into a generator and turns it to, uses it as the base stuff for the generator for this first version. And that would include things like tokens and stuff, right? So that is not something that I think is available for most languages, because they can't get at the languages. So I think I could even do it after it was compiled. So let's say I compiled the parser into a tool of some kind. I should be able to get at the AST of the thing that was used to generate that parser from the tool, which means that the tool itself could regenerate the source code for the thing in some fashion. I don't know if that's true. And you have the different things with like privacy and scoping and all that might get in the way. I don't know. I've never tested that. But thank God we at least have a language where the creators were wise enough to include the AST for the language in the package library, the standard package library, so that we can parse and scan and do everything with things. It's why reflection is so prevalent in usage in the test suites and everything, is because that stuff was included in the language. All right, so the way it feels right now is I really need a clean slate. So I'm going to, rather than just wipe this guy, I'm going to start with a clean slate. That is actually another possibility. I mean, there's not really that much stuff in here already. I've kind of just had to add stuff as I go. So I could just transform all of this. This whole thing is going to be thrown away anyway. So, and again, I don't know if I want the generator code in here right now. I'm going to keep it though. This was some good code. I don't want to mess with this. So, and these are all functions that are another thing I'm struggling with before I get into this new parser is, do I want to actually follow Go conventions of mixed case, or do I want to not and do like this? And I think I've already made that decision. So yeah. Another reason I want to do this is because I'm going to be checking out if I have any namespace collisions between my classes, like I do. Like there's a Unicode class and there's a Unicode node, and how's that going to, turn out? I think it's going to be fine because classes are inlined. All of the classes are going to be inlined. They will not be functions. So yeah. I mean, I might make them functions in the first version, but I don't know. I'm thinking about this because the classes will definitely have name conflicts because they definitely match. So this is really hard because I'm weighing the value of maintaining a package versus having a package that's auto-generated and simulate something that's auto-generated. So for example, this is why I have isFunctions right now, even though isFunctions would never land in the final version. I think the way to do that is to make the isFunctions the structs, and but then it's still a function call for that, and I don't want that extra function call. I don't need it. But I'm going to need the class struct. I'm going to need the class struct anyway because I need to have the information about when it fails. I need to have the verbose error messages and stuff. So that kind of argues to keep the structs, the is classes, and to deal with that. That's the problem with that is that every single one of those is a function call for every character, and that is really expensive if you ask me. I mean, it's probably, most people would be like, oh my god, that's like so fast, why are you even worrying about that? Premature optimization is root of all evil. But we're writing a fucking parser here that's going to be doing a lot of work, and I don't know, so if I write, so for example, if it's a Unicode character, right? Well, when I'm writing these parse functions, do I write them? Well, no, we're going to auto-generate the parse functions. That's right. So we're not going to need that part of it. All right. One thing at a time, Rob. All right. So the first thing we're going to do is the parser. And there's already a notion of this parser already here somewhere. I feel a little bit like my room is dirty here because I got all this other stuff that I don't really need. Is probably an opportunity to do a git stash. But I've never done a git stash, I must confess. I don't use them. So I need to learn about those before I do it. Anyway, another option would be to run a new branch off this and to really transform what we already have into something else. And I think that might actually be the way to go here. So, because then I can keep the two open at the same time. We have the new notion of functions here, and I mean of constants. We have negative constants for negative identifiers for stuff that doesn't need a node. That includes an insignificance. How much testing am I got in here? So a little bit of that. You know what? I don't know if I knew that. You know, I can do the age-old thing. Don't judge me. I'm going to do old, and I'm going to put this other stuff away for a bit because I just got to get my head around the new stuff. And yeah, I'm going to incrementally bring over the other stuff. Obviously, and this is going to commit to this branch. This whole branch is going to get thrown away. So, you know, this is just a really, really dirty. Should have done a stash then. What do you mean doing a stash? You're going to show me how to do a stash? I really want to get good with the stash. I won't lie. I need to learn it. Do I need to learn it right now? Maybe I do. So how do I get stash? I want to be able to get him back later though. Atlassian, yeah, you can go bite me, piece of shit website. If you could do it over blah, case one blah, yes blah, in a dirty working directory away. Yeah, I know. Thank you for the reminder. I need to find something else to say. How to stash changes and get now? Let's get stash changes. Get stash changes. Simply execute the following command. Get stash. Yeah, and we'll develop a push. Say push in a stack. It's called stash list. Pop apply. Okay, nice. All right. Oh. Get stash with name or get stash with a message. List the stashes using get the stash list. Get stash pop, get stash save versus push. So the get stash save command has been deprecated. It's also easier to remember push and pop. All right. Get stash pop, get stash first. So retrieve the last stash. Okay. Get stash apply, similar to pop, but it's different. So get stash pop throws away the stash. That's keeps it in the stash list. Okay. Get stash one file. If you have multiple files modified, you can want to get stash a single file alone. Get stash push path to file. Can use more than one specific files. There we go. Multiple files on the argument commands. That's what I figured would be a thing. Get stash push, get stash untracked files. Get stash show. No longer required to keep a stash entry. Get stash drop. I like these. Let's try it. Wow, he's in Dubai. Yeah. All right. So, problem is I need some of the stuff from the file, if that makes sense. So, yeah, that's kind of the hard part. This all has to be written, but I need to be able to read it. Not this though. Tokens can all go. Yeah, that's actually a problem. PEGN classes, also a problem. This is what I was thinking about classes. We need to auto-generate that. If that helps, yeah. Yeah, I can't have that function there, man. It's just too... It's probably going to get inlined. I would think it would be inlined. It's such a simple function. Please tell me it would be inlined. If that would be inlined, that would make my life so much easier. It would just make life so much easier. I wonder, You know, you're not supposed to think about compiler optimization, but this is a big enough deal that um, you know, the function with defer. No. I need to read. I don't know. Golang optimize compiler optimizations. This is, I'm breaking like one of the cardinal rules of software development. You're never supposed to study how the compiler is going to do anything to your language. It's like really bad to do this. I have to remove debug log code. Remove debug log code line from main function compiler time, or just leave it execute runtime. The compiler probably inlines the function. See, this is these functions that I have are so simple. They have to be inline because they're so small. And I have to believe they are because Unicode does it. The Unicode package uses it extensively. So they've got to be inlined. What I want to know is what the compiler would do and how I could do compiler profiling. And that is something I don't do a lot. Cannot be dropped by the compiler, albeit inline. And I doubt the current linker would drop it. Try the object dump tool. Oh, ooh. Compiler profiling isn't hard. I know, but I don't. It's like, yeah, but here's what we need. This is what we need. We need object dump. Is this going to tell us whether it inlines the functions or not? That's what we need. And if it inlines the functions, then I can keep those beautiful structs, and I don't have to get rid of them, and it'll be much easier to maintain. Hi, Rantic. Yeah, you're making fun of my. Sorry. Go to object dump, binary, press a disassembly of all the text symbols encoded binary. I don't think I knew that this existed. Wow, this is seriously fun stuff here. I tell you what. Let's continue our quest and use this this approach and if you know what's really cool about this is I can actually build a symbol table for this. So not a symbol table, but a lookup table. So it can look up like the class by identifier and then get its function to run. That does mean we're going to have to give our classes their own integer values. Which we don't have, I don't think. No, we don't. We don't have that. We don't have that. So it would have to be a hash lookup. I don't want to do the hash lookup. Well, I mean, all of that stuff can be in the. No, it's all going to be in the node parser. Okay, fine. For the checks would also have to know into the details of it. So we're good to go. All right. So let's do compiler profiling later, and not worry about it right now. And we'll just keep doing this. So this means that this code will stick. This code will stick to. We're just going to rename everything. I'm going to get rid of the PEGN prefix for now on everything because I just want to get something that I can test and use. I'm also going to break it out into individual files, and then deal with what the final one file version works later. So again, we kind of have this middle ground in between, what we're going to have in the final version. Lots of to-dos here. This is actually still Bork. Sigh. Um, yeah, I don't know, man. This one definitely could be stashed. Let's try that. So the generator can get stashed. And you know what? I'm kind of torn because thinking about the terms of how things are going to get generated actually makes the other code I write better because it has to think, about how it's going to. That's how I got onto this whole binary problem, was able to fix that. So, yeah, but I have to be able to just focus on the parser, and the day is ticking away. So, is it get push or is it get stash? Well, it's good to know that exists. Get stash push, yeah. Stash push gen.go gen test.go. Yeah, those two I definitely can. Did not match any files known to Git. What? What? Hey, look, I put work in progress on it. Nice. Yeah, it looks like you do. I do love that it used. That's probably the only acceptable place to put work in progress. In your stash. I put it in. Sometimes I put it in Git commits WIP. I'm like, this is like the worst possible Git message of all time. So why the fuck are you pulling in all that shit? This is why I want to stash everything. Don't need any of that. Okay, so this is going to get all ripped to shreds. And it's about time I do that, so. I'm thinking about the constants first. They're probably easy. Well, I want to do the parser, but I can't do the parser without. Actually, yes, I can. I kind of leave all the rest alone. I just feel dirty. I feel like I need to clean this thing up first. I don't even know if that's still accurate. This is why I have to have a generator, because I just changed the spec and changed some of the names and everything, and now I have to change all those and keep them updated by hand, which is a disastrously troublesome thing to do. Therefore, I'm going to stash this thing. Yep. Push temp stuff. Yes, I know. What else? We got, well, let me go grab the latest. Pardon me. All right. I feel like I need music. Probably a bad idea. PEGN test can go. This was just for the JSON stuff, which also needs its own thing. That JSON stuff's gonna really come into play when we start talking about binary data as values, because we're gonna need to do the whole JSON thing where they use base 64, and we're gonna have to detect that somehow, and we need to be able to figure out how to trigger that detection. And I'm really fighting a tangent on that. So yeah, but I definitely don't want to lose this stuff. PEGN tests go. Get stash push. I should have done all these at the same time. I know, but whatever. Wait. Why did you not leave? I thought the whole point of stash was to make it go away. Why did it not leave? I am sort of at a loss. Okay. Right, the parser needs to stay on track. Well, what I want to know is why this is not going away. And I'm going to make it go away right now. I will get good with stash at some point, but not right now. Yep. The other stuff, I can go. I need to make all these other changes. What are you doing, dog? The dog just knocked the door open and came into the room. What are you looking for? Is it raining outside? Normally you don't come up here unless you're scared or something. So yeah. All right, so this thing I'm gonna rip apart. So I'm actually gonna go ahead and do a commit here. Before new parser. And so if somebody's following along on the branch, they can at least know what's going on. So yeah. And this guy I need to rip this thing apart now. So that's what I'm going to be doing. Mostly I just need to rip out the parser. So this is not going to be that anymore. PEGN class, struct, ident, PEGN description. We do need classes, but not right now. I don't want anything in here that's not a part of the parser. That's the entry, and that's how we were parsing our JSON before this. We're going to need the tokens and all that shit, but I need to regenerate those. Actually, I don't need any of the tokens. Again, the only thing I need is a parser. Rob, stay focused. Okay. Not going to need the classes. I just need this. So, all right. All right. There. All right. And then I can stash this guy. And there's not going to be any marks or any of that jazz. Clean up and prep before new parser scanner. Why? Why is it not removing my files when I stash them, people? Somebody want to tell me what's going on? Working directory and index state. Maybe I got part stash wrong. It removes the changes from head. So if I delete it, am I going to lose it? Yeah, I don't know, man. All I really want is another directory. It's the equivalent of like putting it in a folder for later. That's all I want. And I don't know how to do it. I'm not gonna lie. So, multiple files. Yeah. Yeah, I don't see the value of it then. I'm like, what's the point? I just use my temp directory, you know? Not to mention the fact that I don't want to clutter up my. I mean, I imagine it puts it in the Git tree, so you can just pop them all off, right? Yeah, I mean, I'll have to study this more, but at the moment, I don't see what this brings to the table that's better than the temp directory. It's like I was hoping that it would save those things, save changes without committing them. All right. Well, just to be sure. All right. It's going to want me to add that change. Watch. Yep. Again, I'm just focusing. This is what I wanted. I wanted this clean tree now. And now I can start writing test cases for this thing and everything. I can go back to my normal state of affairs. However, I feel like I need coffee. I finally got past the annoying stuff. So I'm going to take a 5-minute break. Since I read Namasec, Nahemsec actually takes 30 minutes and then 10-minute breaks. I'm okay with doing a little bit quicker breaks, and this is a natural place for me to take a break. So watch the fish when I make coffee. I'll be back. When I come back, I'm gonna actually start the parser from scratch. I'm gonna adapt the parser I have currently as much as I can. But for the most part, I'm just going to be writing it from scratch completely. And I'm going to be leaning heavily on existing parsers from the Go Standard library to get ideas about how to do that. I've studied those quite a bit, particularly the Byte scanner. In fact, I might be able to get away with just using the Byte scanner for this, but we'll see when I get back. Apparently, I locked the dog in the room. definitely a good thing. All right. I'm back. Back. Believe it or not, I'm having fun, just so everybody knows. Sometimes it doesn't sound like it. But I am probably having too much fun. People are like, you really shouldn't rewrite the parser. I'm like, but I have to rewrite the parser because the other one was based on Unicode runes, which we're about to see. PEGN/PEGN go one file. I don't even know if it's going to be one file, but we'll keep this branch alive. We're going to go ahead and run the tests here. There's lots of fixing that I have to do on this, starting with renaming everything. Everything's going to be private. And this is going to be vastly reduced. All this stuff here. Again, trying to be better here. In fact, I could probably just delete every PEGN underscore in the whole thing. All right, what do we got there? Yes. Yep. No, we're not having an expected of any kind. We can add this later. So, yeah, we're going to get this out of here. Styled it out. What is that? That means I slurred my speech. All right, new line. We're definitely going to need a new line, but again, I'm going to copy all this stuff over. Code compiles, that's always good. Buffered input is good. Yeah, I mean, a lot of this stuff I don't need to be particularly overwhelmingly complicated. So, going to be massive simplifications happening here. Lots less clever. This is going to be a big thing, though. The position is going to be a big thing. I need to keep some semblance of that. Unfortunately, it's not going to be able to have the last byte scanned, so this might have to change completely. In fact, so much so that I'm just going to rip it out. Init is something I want to keep. Init allows me to reset the parser and reuse it without throwing any resources away. It's also a common idiom. I do have a question about whether to do things public or private, and that really depends on whether anybody else is going to have access to the parser. So yeah, this decoder and thing, this is all garbage. So we're going to have this, but we are just going to return nil, and I'm gutting everything so I can redo it. End of data is a very important constant that will remain. And yeah, this is a PEGN constant, though. I'm going to call it EOD, and it will be named to be a part of the parser. Actually, I could make that a function of the parser. Let's do that. Let's make it a property. Now, if I do that, I can't make it a constant. It'll be changed. You can't make constants, but okay. Constants are going to get inlined anyway. So yeah. I don't even need it because I'm not going to do this whole last byte crap. That's not a thing. Last byte, next byte is gone. Last length is gone. Last is gone. Buff remains. The IO input reader remains if we had one. The current position and offset runes. Yes. 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 the line column, the line byte. Yes. Those are going to likely remind. I kind of want to make them their own struct, but that's okay. We're going to keep it. I'm going to make them smaller, though, because we're going to be using them a lot, and I don't want to. I don't like column. I like line. Arg, 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 arg to the arg. Here's the problem. How do you resolve? All right, so we're moving to a byte parser, and that's well and good. But how do you resolve positional information to be sent to the user who's going to expect lines and stuff like that? So, and have it still be in the parser, right? It's almost like the parser has two things. It has the byte parser, which is the thing we really care about, and it has the userland position in terms of runes and such. And that's really up to, you know, Yeah, I feel like we're throwing the baby out with the bathwater on this, on some of it. Because while I wanted, be able to parse bytes of any kind that are not Unicode runes, I like the idea of giving the position in characters that are visible for most everything, and that's what we had in the other parser. So that leaves me at a loss because I'm trying to figure out how to resolve that dilemma. And honestly, the first way that comes to mind is to separate them completely, so that our parser is only interested with bytes. That's it. It's like a bare bones byte scanner. That's all it is. In fact, I really do need to look at the Golang byte scanner and get a sense of this, because I actually probably could use just the byte scanner that comes with Go already, and then I wouldn't have to do any byte scanning because we're only moving one byte at a time, so there's probably already a thing there. I already have a scanner for that, in which case I just have to give it a buffered input stream and we're done. And that's like really great if that works. And I'm almost positive that does work because you can set your scanner function. I don't know if it's the highest performing, but it's fine. But then the reason I'm going down this route is because I'm already talking about separating out the userland notion of lines and columns from just raw byte scanning, and rather than trying to smush the two into a single parser / scanner. So what we could do is we could maintain, if we do that, then in our function, the thing that the parser or whatever we have, the parser would have embedded in it a scanner, and the scanner would do its thing, and then we can provide ways for the users to increment the line, which has to be done in the parse functions that are generated by the grammar anyway, because in fact that's something that's implied. I need to put that in the spec. Where is that? I don't think that's in the spec right now. No, that's not it. I need to make sure there's a comment in there. I thought there was already, but so there is a special thing here. So inline, it's really important people know. I already commented about this before, but I don't think I put it as explicitly as it needs to be. So in the PEGN grammar, nline is a reserved, and I need to put this here. I said put will set new, let's see, So this is the res check ID can be overridden. Will reset line. Parsers must reset line. I don't know how else to say that, but if so, we have this notion of an end line, and if you set an end line in your PEGN grammar, automatically the code, the generated code, will produce something that increments the line in your usual land position information, however that's generated. And so that's important because people have different ideas about what a new line is. All right, so back to an exploration of the scanners that are already available. I know the Golang scanner is one of the best ones. I've actually studied it quite a bit. And by default, it scans. This is how you actually read standard input, by the way, which is kind of interesting. This is the standard way to read standard input from the command line. There's no input like there's in Python. And there's a bunch of scanners. The text scanner, there's the Go scanner. The Go scanner is the one that actually scans Go code. It's part of the actual Go command. This is the thing that produces AST. A great place to look for highly optimized code ideas. Yeah, so, and I have this all as well. I can look at it in a better way, but so UTF-8 rune self. I want to believe that a lot of this stuff is being optimized because there's a lot of function calls here, right? Again, this is not a high performance scanner. It's good, but it's not like super high performance because it's just scanning Go code, right? Only for minutes the very first mark. Yeah, this is all the. Yeah, we're gonna skip this scanner here, and text scanner is the standard library for doing this kind of thing. Here's an example. You just you set your new reader, which is what I'm doing on mine, and then it actually has a file name, which is kind of cool. So you can actually scan multiple files. And I remember the POS, the position struct in this thing. It actually keeps track of what file you're scanning, which is kind of cool because you can, that's something you can't. It also keeps a byte offset and a rune offset within it, if I remember right. Yep. See, and it has this whole printf idea. It tells you where it's at any given time. So yeah, it's a pretty nifty little scanner. It might be enough for everything. I don't know. New scanner. I know you can set the function for the scanning if you want to. If you don't want to scan by word, which is I think is the default. Yeah. Is ident rune. Scan token into EOF. Scan into file time. So scan. Yeah. Yep. You see what they did here? They actually have an is function. I don't think I saw that before. So, yep. So they have set one of their is functions to be a thing. That's kind of what we could do with new line if we wanted to. But this just further indicates to me that using functions for our is functions is fine. They're going to get inlined away when we profile the compiler and find out what's going on with the underlying code. So yeah, return stations blah. Unicode is letter. Unicode is digit. See, look at this. See that? See that? Look at that, man. That's exactly what we were doing in our is functions, and I'm like all flustered because I don't want them to be overly slow. But that's misplaced concern. This is very clearly, a very effective way to do this. So yeah, that is literally an is function. And I'm just wondering if is ident ring was a part of this of the package. I don't know yet. Let's go see. So here it sets up a new reader. Scanner.skip comments. What's that about? It looks like this is. But you know what? It's scanning text, and I have a feeling it's gonna choke on bytes. Bet you anything. I think there is a byte scanner though. To tell you the truth, I'm gonna have to go look for that. Look at this. That's pretty cool. So yeah, it's scanning, row plus plus, column plus plus, blah blah blah. Init, next, peek, pause, scan, token text. Not gonna be enough. It's not gonna be enough because it only shows me one ring at a time. I can get a lot of stuff from this, but this is not nearly enough. This is just one token at a time. I mean, I can get a lot of ideas again from that, but so can't scan raw strings, blah blah blah. These tokens, Unicode characters. Yeah, so here's all the tokens you can produce. It can't produce nearly this kind of things that we want. This is not nearly good enough. I'm pretty sure there's a byte scanner too, though. I can't remember. The buff.io scanner. Yeah, that's the one. Scan bytes. There we go. And that's the buff.io scanner, if I remember right. Yeah, this is different than the text scanner. There's lots of scanners in the Go package. And parsers and tokenizers and all that. Scanner.bytes. So we get a new scanner, buff.io scanner, a new newsreader, which is perfect. Scan. Length of the bytes equals 6. Scanner.bytes. That's kind of weird. I don't want to scan all the bytes at once. If error scanner.error, blah. Should see an error scanning a string. So I wonder if we can input our own parse functions in there. Scans the message to the next token with the bytes or text method. Returns false when the scan stops, either by reaching the end of the input or an error. After scan returns false, the error method will return an error that occurred during scanning. It takes care of a lot of stuff for us, so I don't know. I think it might be good enough. Splits the function. Sets the split function of the scanner. The default splits function is scan lines. Yeah, we don't want that. Oh, right. This is the one that reads standard input. I forgot. This is the one that's buffer.io. It's not text scanner. So this is the standard way to read in lines of standard input. Going to scan as a newly allocated string holding its bytes. But I don't understand because I only want 1 byte. Writer implements buffered IO for IO writer objects. No. Comma separate list. If it's taken by 1 on comma. Define a split function that separates on commas. Do we seriously have to have a split function for everything? I don't know, man. I don't want that. That's like way too much overhead. This isn't that big a deal, man. We don't need all that. We don't need all that. So, I mean, this is nice, but this is kind of userland stuff, and I don't want to use userland stuff. Not for this, because I want to be able to rewrite it in C as well, and I don't want to depend on some userland scan standard library function. And I'm not just trying to be difficult here. That's because I want to be able. The resulting thing that comes out of this parser has got to be implementable in as many possible languages as we can, because that's going to be auto-generated when we generate Rust code and C code and all that other jazz. Which means dealing directly with the bytes and writing our own minimal scanner is the best way to go. But getting ideas from those other scanners is probably fine, of course. So, we have this notion of reading something in, and then that just keeps a hold of the reader that we had before, and we have the buffer. This is something that none of the other scanners are going to do. We're going to load that whole buffer up. And that's a very PEG thing. PEG enables us to assume we have full access to all the data. And if we want to do another file, we load up that file. And that's, heretical, but whatever. Again, back to the question about position in lines, we don't need it. We don't need lines. I'm not going to keep any userland stuff here at all. The problem with that is that the parse functions that we generate are not. I mean, the node parser functions, I should say. Like that are responsible for just finding a node and returning an AST. And the check functions are going to need to know something about the position. They're going to need to keep track of how many runes they've been counting up, because in our particular case, we care about the runes. Now, this is another thing that's dependent on the grammar. So, for example, I have to talk through this. I'm sorry, but I just do. So, this particular grammar that we're parsing, which is the PEGN grammar, so we're using PEGN to parse PEGN. The idea of lines is very significant, but one of the motivators for doing this entire different parser is so that we can start to parse data files that are not Unicode. And I know that's an extremely exceptional case, but we need to think about what happens when I want to parse, I want to unpack a bit field. That's three, and that's actually, I really, really want this, because I want an equivalent of unpack that you have in pack and unpack, which you've had in Perl all these years. So you can take a bit field or a number and then convert it into its parts. And I kind of want to get that equivalent in the resulting thing that comes out of this. So we can write, instead of writing inline regular expressions, we can also write inline bit field things. And they would have to be, the problem with that is that they must represent 1 byte. Minimally it would have to end on a byte, because that's what it would be. But you could represent TCP/IPs, packet, and you can put that in there and then represent it inline, and then not have to and it would parse, and it would actually generate a parser for you. You could validate it and all that stuff. And all of that stuff means that we need to be able to have a parser that's byte centric and potentially doesn't give a shit about lines. And so that means that that honestly, I've been really harping on really usable user errors that are really easy to digest and everything. And that works great when you're working with Unicode. But as soon as you start working with this other stuff, knowing what line you're on, goes out the window. So how do we add that back in a way that is fine? And I think I just talked myself into the solution, which is usually what I do. We need to ask in code, when we generate code, to say, do you want line, I don't know, line position. Do you want, I'm going to call it userland, line position information. And the default is going to be no. And the reason for that is this going to actually change what gets generated. All right. Now I'm gonna finish this parser because I want it to work and I want it to be done, because I'm going to start doing code generation, and that's what I need it for. So I need it to be finished. So I'm going to leave that off for now. But when someone says yes to that, when we're actually doing code generation, what that's going to say is, not only do I want, this bare bones, uh, parser that just knows about what byte it's on and that's it, but I also want this notion of lines, and so and that means that the parser functions that get generated will then have this idea of line put in them, and if they've defined end of line in their grammar, that will automatically be code for that will automatically be generated to trigger a new line reset, and then we have a POS and all this other stuff that gets added for userland stuff. So that would be a completely different type of code that would be generated from that, and that frees me to just focus on nothing but byte parsing right now, and then I can come back to that without having to, have the overhead of thinking about what's going to happen with line returns, and is that offset, and counting, and even stuff like counting, if you're doing runes, is like counting the runes, and say, that would be, that's probably another thing I should put here. Is your grammar Unicode centric? Grammar binary contain binary represent. Let's see. Does your grammar represent binary data? No. And if it doesn't, then we can assume it's Unicode. And that would be a yes, and that would generate a different. We would have a different generator. I'm kind of, cognitively stashing these thoughts so that I can come back to them later, and then just get on with the business of doing all this stuff. So I'm just gonna put buffer here, and this is all the same. All this does is it reads different types of things and buffers it all, depending on how it's sent in. It allows me to do testing based on strings. I don't have to, get crazy with it. That's definitely going to stay. Init is going to change back to a lowercase init. Again, this parser is not being written for anybody else to use. This is designed for just me to use, which is, writing off way to use it number 3, which is, for education and stuff. This is designed to be optimized and embedded eventually. All right, so that means things like next and all that are going to be different. We're not even going to have a next, actually. I don't know. We'll think about it, but yeah. Yep. Yep. I don't know about any of this. We're definitely not going to do a decode rune. That's definitely gone. So I mean, I almost don't feel like we even need to do that, because what I can do, if it's a simple enough parser, I can access the struct directly, and I can say this is the current beginning and this is the current end. I'm going to do that. So beginning is an int, and end is an int. I just need to, I don't know, we can do pointer, we can do cursor, current, we can do current. Let's do current. And don't need next, because we're going to be setting that in the parser. And this is something that is, this is, the node functions that come out of this are not going to be autonomous, independent things. They're going to have internal private knowledge of the struct. That means they have to be in the same file, if not the same packages, if not the same file. And some people would say that's a bad idea, but in this case, it's totally fine, because it's all going to be in the same file ultimately. and therefore giving it direct access to the struct is something that's a very C-like thing to do. It's not violating encapsulation in any way. It just means that the method the function is going to be able to get to that. In fact, what's the plugin for Twitch? Vim chat. There's no such thing as Vim chat. This is WeChat. Yep. If you go to rwxrob.live, I have my FAQ there. Go read about that. Okay, so then we have a buffer here, and we have our init, we have our move. So all of this stuff is completely useless now. Because why? Because we can use direct access to the structs. This done is done. This new line is user space. In fact, parser is just a number. At the end of the day, it's like a buffer and a number. Where are you? And that's it. So other than, loading up the input, hell, I don't even need that, really. All I really need is the position in the byte stream, and I guess it does make sense to kind of keep these things together, I suppose. But yeah, so don't need much more than that. And let's be real, I'm not going to need... the init function is just a utility, so I don't have to make a new parser every time. So yeah. This could almost be the init function, actually. Huh. I don't even need the init. Init, all the init does is reset the numbers. That's it. That's it. So, I mean, that's not even that big a deal. So let's do that. So, no. So, okay, so buffer would actually change out the stuff in the buffer, but wouldn't change the numbers. So that's not something that should generally be called. But I think I can get rid of yet another function, and I can just call this init. All I have to do is add the resetting of the numbers, and we're good to go. Which we already have. I just don't have that here. I mean, that's literally this. I guess I should say that until after we get down here to success. So the current position is 0, and that's it. That's really all there is to it. And yeah, and then we put functions on this. PEGN refactoring. Yeah, we're rewriting the parser. I mean, look at how tiny that parser is now. That's it. That's all we need. That's it. That's it. And so now what I need is to start writing what I anticipate would be parse functions that use this. And I need to write a couple of those, at least in testing, to show how it's going to advance and how it's going to do everything, and what other pieces do I really need. But at the end of the day, beginning of the day, all you need is a byte buffer, a current position in that byte buffer, and that's it. Everything else can be kept track of by the functions that are using it. And apparently there's probably going to be a few, utility functions that come out of this, or methods, but yeah, but for the most part, we're good to go. So let's actually start by testing just this. All right, let's test our init and let's test our parser. And God, I'm glad we're doing this. This is making me happy because this is minimal, and that's really what we needed. I'm gonna make. I'm not even gonna use example tests here. I guess I could, but I don't need them. I'm going to use regular good old tests. Func test test parser. This is testing the parser struct. So testing.t. I should probably do a benchmark here too at some point, but whatever. T.fatal. Fatal. Boom. All right, so we need to make a test of some kind. So let's just, I mean, come on, this is not hard. So let's do, I mean, do I even really, yeah, I guess it's not really a parser, is it? I mean, it's not a scanner either. It's, you know what, let's just keep parser. We've been calling it parser all along. Let's just keep it. All right, so parser, and I can do that. I don't need anything fancy. I can do a new parser, and p decode but not used. Println just to show you what p is. Yay, it's nothing, right? So yeah. It's got all 0 values. It's good to go. Let's just init it. So we need to do it with p.init. We'll give it a string. That's not a string. And yay, pass. So there's no such thing as assert in tests. You got to do it all long-handed. Long-handed. This is why people use testify for this, but I refuse. But I might write my helper function. So if did they add asserts? Let me go check. It's been a while since I've looked in on tested on the Go test, the standard test library. And there's been like 3 major releases since then. And so I need to look at the testing package real quick. I think they may have added some of the stuff. Error F got whatever. Benchmark testing. There's a good old example outputs. I love those, but it's actually faster to write that than it is to write the if thing. Plus you also get to see what comes out. It gives you the whole want got kind of thing for free. You don't have to write it. Yeah. You know what? I'm gonna shamelessly use expect functions, except for I'm not gonna put them into context. So I'm just gonna use them here. Fuck that. You know why? Because it does the want got much better, and it's all very visual. It's easier to write too, frankly. So just so easy. Pass. Make it fail. There we go. So println. Let's print a p and see what we get. We get nothing. Print p dot. Well, that's the whole buffer, right? So that's kind of cheating. If I make it a string. So yay, there we go. Got string. Pretty fast test there. All right, let's do another one. This is and the advantage of this is if I ever decide to make any of these public, I can still use this example, so it's not completely wasted. We need a reader. So I need to use a string reader. I need to look it up. Strings dot new reader, I think, is what it is. Pass. Wow. I am a string reader. Oh. Glad I remember that. Save me time. So string reader, I mean, this is good. I mean, I don't want to mess with anything. What else we got? String reader, a string, and a byte string, I think, is the other one. Byte string. We'll make you into bytes. How about that? All right, you're good. So far, all of that is working. It's just a regression test, pretty much. Let's see what I got on coverage. I should probably start doing coverage more during the process. Oops, we're missing an IO reader. That's not a case I can test very easily, so I'm not going to mess with that. Parser unsupported. Oh, let's do an unsupported one, and then let's do a zero length buffer, and then we'll have a full coverage, 90% coverage actually. 75. Let's get a little bit better coverage here. It's a good practice to do this, by the way, to do coverage as you go. In case you're wondering, that little tool I ran is a little gem. I am so happy I have it. It actually converts the normal coverage output in HTML into stuff that will display using links, and then I'm able to access the coverage file using a links browser from the command line, which normally would fire up a graphic browser and be really annoying. So it's a super nice gem. If you want one, here you go. You can have it if you're in the Twitch audience. Otherwise, you can type that in, and you can go grab your own. It's like really, really cool. Of course, you have to have links set up to do that, but it's 1,000 times better than the built-in Go coverage tool that forces you to use a graphic browser. I hate it. So, kill this. All right, here we go. Wait, what am I doing? So, oh yeah, a little bit more code coverage here. And we need one for, what do we need? We need one for we need a case where we have something that's zero length. So let's do that. Let's change reader. And then we'll have, yeah, that's going to be an error. It's going to crash. We're not even checking the error conditions on this other stuff. So we should do that too. That's going to be null. All right. Put another error here. What are you talking about? God damn it. Yeah. All right. I'm a string reader. I am a string reader. No, down here needs to be whatever the error message is. God damn it. That'd be 0 on that one. Let's do. That's gonna be parser no input. All right, and then we have the last case. I mean, it wasn't that hard, right? We still have a ways to go to get into other stuff, but oh well. We have a 0, and then we have an unsupported input type. So if I put it like a number here, unsupported input type. All right, so that is 91% coverage. So that's good. We're off to a good start. Obviously, it wasn't too hard to do that. But, you know, it's good to start small and really, really shave. I'm just going to be draconian with my, you know, not adding stuff for convenience, unless it really makes sense. So again, we copied to the init, all the init and the buffer initializer are in there. Actually, there's one last test case that's not covered, and that is to re-init. And I want to find one of those. So let's say, all right, I should be able to re-init. I do this in all my tests. So we'll have a string reader, and then print that out, and then we'll do another one. And this is going to be, so that will be this. And that should be, oh, whoops. There we go. So I want to make sure that it resets the whole internal buffer. And so yeah. I think that I think I'm going to leave the current position things to the parser itself, and we'll call that a day. All right, so that is done. It's actually savable. So all right, so I'm actually going to cheat and use my tool here. So okay. And yeah, that's good. I'm going to go get a drink. I'll be right back. Next, we're going to actually put in some stuff to parse, and we're going to simulate parsing with a parse function. Then we're going to keep this very functional, and we're going to keep our parse functions down to 1 argument inputs. And that's it. I'll be back. Back for another shot at this. We're gonna make a parse function so that we can do this. I actually am really curious to see about the profiler now that I know about the compiler profiling that we can do with Go to see if our parse functions actually end up inlined. I have a feeling they do. If they do, that would just be so ideal, and I want to actually study that. So yeah, let's do this. So that means I'm going to have to actually write some parse functions as a part of a test, and we need to kind of put out, let's do that. Let's define. There's nothing wrong with defining this as a type, even though it's going to be a thing here. So let's go ahead and add those. We definitely need the node tree in here too, and that's gonna start to come into effect very soon. Mostly because the parse function is going to need to return a new node, or does it? I wonder if I could just have it return the byte slice and then inflate that into the node by the container, the thing that containing the caller. So yeah, so this has been a really helpful rabbit hole because it's like the third tries the charm, on the parser. I remember Pike in a video talking about Lexing with his channel parser for this text template stuff he did. He was like talking about how he did one parser and he threw that out and then he did another one. As long as we keep pushing forward. So what I'm trying to talk about here is we're going to need a function type. So the function type here is going to be, I'm going to call it just a parse function. We already have a parser, so, and we could almost encapsulate this as a struct. And I've been thinking about that because then we could document each of the node types. And let's talk about that. So that would be I don't want to call it a node because it's not. It's a node parser, but I mean, we could make it a node and then have the information about the node contained within. So we did this for classes, for example. And frankly, you know what? They could follow the same model. Both of them could follow the same model now that we're returning a string. Because the classes are just returning a 1 byte string. And we are pretty sure we're going to keep classes and nodes together this time because there's not a need to really break them out. And we have to bundle those is functions with. We can't. Okay, that's the reason we can't, because it's not going to be an is. It is, if it's not an is function, there's a really good chance it's not going to be inlined. So that would be a no. But they both could have descriptions. So let's do that. So this is we have a description. This is a big part of this actually. So I want to keep this in here. This is where somebody would normally do an interface, and I'm actually going to embed a struct, and I don't want anybody to scream bloody murder. It's usually this is very OO like Java thing to do, even though it's not inheritance. It looks like it, but it's not. So in our struct we're going to have, so we have the ident, which is string. We already have this for the class. We already did this. And then what? Then we have the PEGN string, and then we have a description string. And then I'm just throwing stuff out there. So nodes, this is interesting because this is going to be different than a node from like the node tree. Or is it? You know, what if we allowed our node tree to be specific? You know, I've already departed from the I want to be able to use it anywhere thing, because I've got that already. I can demonstrate how to make a node tree in a way that's generic and anybody could use it. But it's more valuable to me to have a usable node tree that is using nodes from my domain right now. In which case, I don't have the concern about using the word node is unjustified. I can make that into the node for the node tree and for the parser, because they're all the same. Again, I'm going to stick with structs for this. If I have to do an interface on top of it at some point, I will, but I'm not going to right now. So what is a node? Well, a node has an ident, has a description. Yeah, student apartments are hell. I believe it. So nodes have a description. You know what else has a description? A class. Difference is this has an is function. And the is function actually is going to take this is tough because I can do it two ways. I can actually I can do this. I can do type is a function that takes a rune. Actually, no. It's we can't use is functions anymore. You know why? Because we're not looking at a single value anymore. That's super interesting. That means class function, the notion of the class is going to have to be pushed into the notion of a node or check, whatever you want to call it. Yeah, I'm going to change this into a check. So this is a check, and all it does is check to see if the next thing is there. And if it is, it returns it. It returns that value. So we'll say check is I mean, we can make it a parse function too. Let's do func, and we'll make it return a string and an error. Pretty common. So actually, no, we're going to make it a byte array. And no, we're not even going to do that. We're going to return the ending location of where the check was found. So we're going to return an int. And that int will be the last character of, actually, yeah, the int will be the end of the character from that, the offset from where we're at. So from there to that point, we've got, that's how far you can go. So if we do, so that would be like the last, yeah, and we're going to need to check this right now, but, yeah, so this function takes a parser, a pointer to a parser, and it returns an int. And it doesn't advance the parser though. So the advancement of the parser is left up to the check function. Or to the, yeah. Let's change this to check. And so yeah, that's it. And then this is like, I'm going to put end error. So
kind of gives some information without writing any documentation. And so we have our description that allows us to write lots of different checks. And those can be auto-generated from the grammar at some point. And what else do we get? Well, it's time to start checking it and seeing what one looks like. And that's probably going to go in another file. Now, this is another thing where, I have mixed feelings on this because there's going to be literally 80 checks. So, I don't know if I want to put them all in here just like strewn about. I kind of want to put them all in the same file, but it needs to be a separate file. More importantly, though, I need to do some basic testing using this first. So let's do that rather than start writing a ton of checks. So yeah. And let's make one check and then call that as a test. So parser test function example example check. All right, and then what? We make a new parser. Yeah, we're getting kicked out of our apartment. Yep. No fault of ours at all. They just want to sell the place. Greedy fucking boomers. Greedy Republican boomers. Sorry, I swore. I swore I wasn't going to swear, and then I swore. We need to liquidate it. We need to liquidate the asset. That's literally what they told us on the phone. Literally. That's the exact words they used. Like, really? Very nice. Why didn't you tell us that like a couple of years ago when we told you we were going to start a school in this location? Yeah, they don't give a shit. People don't care about each other anymore. Yeah, it's a really good thing COVID hit. If COVID hadn't hit, I would be out of a job because my business would have been decimated. It was already beat up by the last landlord who kicked us out and gave us 30 days notice. I want the space for my office. I'm like, great, I've been here for 7 years and you're going to kick me out now? Actually happened. So we're not renting anymore. We're going to live in a tiny little apartment. We're going to save up our money, and we're going to move into a home in the middle of nowhere. I'll continue to stream and work for someplace remote. My wife will make fantastic art. She just put in another gallery today. Not a full gallery show, but yeah. I could play by the other fucking game. I don't want to. P declare but not used. Okay, let's do this. Let's do a P dot. We'll start it up with a bit of something here. I am a string, and don't really need to print anything out here, but we do need to parse it. So let's do that. We got to make a parser. So how do we do that? First, we need to make a parser. So make a check. C equals, let's say our check equals a new check. And I can do all kinds of things with this. So, I mean, I could do it using a composition, but I'm just going to do it this way. So I could then check dot ident equals random. How about the IM? How about that? IM. And empty print. This is what I probably want to do, is c.print at some point. This is really annoying. Yeah, I mean, this is just a check, but bah, 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 bah. It's hard for me to get sucked into all the other ways that you can, all the other stuff you can do, like to represent your check. So yeah, yep. And name, I mean, PEGN. So the PEGN for this is literally the word I and the word M, and then what, Doris?
Can you or no?
Can I go for the walk? Yeah, I guess I can. All right, guys. I'm actually going to cut the stream and go for a walk. It's going to take about 20-30 minutes. When I come back, I'm just going to be writing more boring checks, and we'll get into the parsing thing. I'll write my first parsing function. Last thing to do here is the description. All right. The word I followed by the word M. Can it use the word I as type string? What are you talking about? Bullshit. I mean, something else. Why can I not use that? DESC. I don't know if you noticed, but this is a cool thing about Go. So you see c.ident and c.PEGN. Those are actually resolving to c. What is it? C.DSC description. Oh, that's why this isn't working. No wonder. Okay, because I have a name that just disagrees with the name. I didn't peg in description, so it gets have. I'm going to say info. It has metadata. Meta. I don't know. We can say it's a component. Yeah, what's that? So, or is it, what is it? Is it definition? I guess we could call it definition. Yeah, it kind of is. Why not? I might even be able to combine the node thing and get a better domain model out of this. So I'm actually kind of happy about that. It's going to be totally different than the first version, but yeah. So all right, so I probably need to make that so it prints better. I mean, come on, that's pretty ugly. Yeah, I mean, yeah. Yeah, yep. I'm gonna have to go. Yes, I do need to go. We're walking the dog. All right.